Hey everyone, go ahead and title your notes Lesson 1.3 Absolute Value Inequalities. So today we're going to look at just our basic form of solving absolute value inequalities. We are going to look at some scenarios in our next Zoom meeting together. So we're going to start off with our essential questions. How can you use what you know about graphs and linear equations to solve absolute value inequalities? In order to solve absolute value inequalities, we first need to rewrite them as their equivalent compound inequality. So basically what this means is, just like we couldn't solve absolute value equations by leaving the absolute value symbol in there, we can't solve absolute value inequalities by leaving the absolute value symbol. So we need a way to rewrite these. So I've made a table here, and I suggest copying this table down into your notes because this is going to be your lifeline when you are solving absolute value inequalities. So we have four different types of absolute value inequalities, and basically the four different types break down into two types. So our first two types are when our absolute value is less than a certain number or less than or equal to a certain number. So what I've written here is the absolute value of ax plus b is less than or equal to c. Ax plus b here, that is basically just whatever's inside your absolute value symbol. So for instance, you could have x minus 4, or you could have 2x plus 5, or you could have x minus 3. And whatever's inside your absolute value symbol, that's your ax plus b. Okay. The way we would rewrite this is, for both of these, is negative c is less than ax plus b, which is less than positive c. Or for our or equal to symbol, negative c is less than or equal to ax plus b, which is less than or equal to positive c. So basically you're taking that value that it's less than, and you're making it negative and positive, just like with equations, and then you're putting whatever's inside the absolute value symbol in between those two things. Whenever we solve absolute value inequalities, we can write that answer on a number line. So you would solve for x, and you would get basically two numbers for x, which you would plot on your number line with either a closed circle or an open circle. If it's strictly less than or strictly greater than, we use an open circle, and then you would connect those two circles. If it is less than or equal to or greater than or equal to, you use a closed circle, and again, for this particular absolute value inequality, you connect those two circles. The last two absolute value inequalities that we have are when our absolute value symbol is greater than a certain number or greater than or equal to a certain number. When this is the case, our inequality is opening up towards our absolute value symbol, so it's like that alligator mouth is about to eat the absolute value part. We rewrite these as ax plus b is less than negative c, or ax plus b is greater than positive c. Now, it's not like pick or choose. You have to write both of these. We just use the or as like a term in math to saying that it's going to be this or this, but we have to write both. And the same thing goes for less than or equal to negative c and greater than or equal to positive c. Now again, we have that negative c and positive c, just like the absolute value equations. We have two equations here. So when we solve, we get two solutions. And these two solutions go on your number line as open or closed circles, and this time our arrows go away from each other. And if it was a closed circle like this, our arrows again go away from each other. So we're going to do a few examples here. Our first example is the absolute value of x plus 3 is less than 4. Okay, so whatever's inside my absolute value symbol, that's my ax plus b, and then whatever it's less than, that's my c value. So this time, the first thing I have to do is identify which inequality I have. So my absolute value is less than a certain number, so that's going to be option 1 here. So what I have to do right now is rewrite this. My c value is 4, so I have negative c less than ax plus b, which is less than positive c. So I'm going to have negative 4 less than, my ax plus b is x plus 3 here, which is less than positive 4. Now that we've rewritten it, we want to solve for x. So I'm going to split this up into kind of like two equations here, drawing a line down where each of my inequality symbols are. I need to get x by itself in the middle here, so I need to subtract away that 3. If I subtract away the 3 from the middle, I also have to subtract it away from the right and from the left. So I'm going to do that, and then I'm going to go ahead and simplify. Negative 4 minus 3 is negative 7. I bring down my inequality. I bring down my x because I didn't touch it, and then 3 minus 3, those cancel. Bring down my inequality again, and 4 minus 3 is 1. So I'm left with the inequality negative 7 is less than x, which is less than 1. And basically what this tells me is that my solution for x has to be in between negative 7 and 1. So it's any number in between negative 7 and 1. So now that we've solved, we have to put this on a number line. And I want my number line to show at least from negative 7 to 1. So I'm going to just go from negative 8 to positive 2. So go ahead and make your number line as well. Negative 2, negative 1, 0, 1, and 2. Now I have strictly less than here. And when we have strictly less than or greater than, we use an open circle. And if we have less than or equal to or greater than or equal to, we use a closed circle. And the way I remember this is if you have to make the extra effort to draw the little line underneath, you also have to make the extra effort to close your circle and color it in. So we're going to use open circles at negative 7 and positive 1. And since x is in between those two numbers, we connect them with a line. And then what we want to remember is that we should always check our work. So in order to check here, we could just pick any number in between negative 7 and 1. So I will pick negative 5. So I have the absolute value of negative 5 plus 3 has to be less than 4. Negative 5 plus 3 leaves me negative 2, and that has to be less than 4. The absolute value of negative 2 is 2, and 2 is less than 4, so that checks, and we are good. So let's look at another example following these same steps. I have 6 less than or equal to the absolute value of 2x minus 4. So the first thing I need to do is identify which type of inequality I have. So in order to do this, look and see where your inequality is opening up to. This one's opening up towards the absolute value sign. So we are opening up towards the absolute value sign in 3 and 4. And then in order to choose between those two, you look for whether it's strictly less than or equal to. So we have the greater than or equal to one here, so we're using option 4. So we're going to rewrite our equation with both of these equations. Ax plus b is less than or equal to negative c, or ax plus b is greater than or equal to positive c. So our c value here is at 6, and our ax plus b is this 2x minus 4. So we'll use that to replace this general form. So we have 2x minus 4 is less than or equal to negative c, so negative 6, or 2x minus 4 is greater than or equal to positive c. And then from here, we just solve both equations. So I'm going to draw my line down, separating each side. The first thing I want to do when I solve 2x minus 4 is get rid of that minus 4. So I add 4 on both sides, and I get 2x is less than or equal to negative 6 plus 4 is negative 2. And then my last step is to divide away that 2 out in front, and I get x is less than or equal to negative 1. I'm going to do the same thing on the other side. I'm going to add 4 on both sides first. In doing so, I get 2x is greater than or equal to 10, and then I divide by 2 on both sides, and I get x is greater than or equal to 5. So now that I have those solutions, I have to graph this on a number line. So I want to make sure I'm hitting all numbers between negative 1 and 5. So I'll start at negative 2, 1, 2, 3, 4, and 5. And I'm going to be using closed circles because I have less than or equal to. So I put a closed circle at negative 1, and I put a closed circle at positive 5. And then I just kind of read. So I have x is less than or equal to negative 1. So if it's less than, we go left. So my arrow here has to go left. If it's greater than, my arrow goes right. So my next part, x is greater than or equal to 5, my arrow goes right. And this matches our picture up here for option 4. So now that we have it graphed, we can go ahead and check. I'm going to check two solutions here. I'm going to check one for less than -1, and I'm going to check one for greater than 5. So I'm going to first check -2. So I have 6 is less than or equal to 2 times -2 minus 4. 6 is less than or equal to the absolute value of -4 minus 4. 6 is less than or equal to -8, the absolute value. So we get 6 is less than or equal to 8, which checks. And then I'm going to check a number greater than 5. So I'm going to check maybe 6. So the absolute value of 2 times 6 minus 4. I have 12 minus 4. And then I have the absolute value of 8. So I get 6 is less than 8 again, which checks. So we're all good for this one. So the same thing applies for absolute value inequalities as absolute value equations. If you have anything on the outside of your absolute value inequality, the first thing that you need to do is isolate. So for example, I have the absolute value of -5x plus 8 plus 2 is less than 25. My absolute value is not alone right now. I need to get rid of that plus 2. So before we rewrite anything, you need to isolate. So subtract 2 on both sides, and we get the absolute value of -5x plus 8 is less than 23. Now that it's isolated, you can go ahead and identify which type of inequality you have, rewrite it, and solve. So I have my absolute value inequality opening up to our number here. So that is going to be type 1. So type 1, I'm going to rewrite this as -23 is less than -5x plus 8, which is less than +23. And then from here, I'm going to solve. So I'm going to subtract 8 on both sides. So I have 23 minus 8, which gives me 15. And then we have -5x because those cancel. And then -23 minus 8 gives me -31. And then I'm going to divide everything by -5. When we divide by a negative, this is something that we should star here. When dividing by a negative, you have to switch the sign. Switch the inequality. So right now, all our inequalities are less than. So we're going to be left when 31 over 5. We switch that inequality to be greater than x, which is greater than -3. And you can always rewrite this backwards, but we end up with 31 over 5 is greater than x, which is greater than -3. And then we graph that on a number line. 31 divided by 5 is about 6.2. So we want to go from -3 to about 7 on our number line. 4, 5, 6, and 7. And then we have strictly less than, or so we have open circles here. X is in between -3 and 6.2, so we connect those with a number line. All right, so let's go ahead and summarize this. Summary: an absolute value function. Oh, sorry. Our summary here is in order to solve absolute value inequalities, you need to rewrite them. All right, so in our Zoom meeting next, we will look at some actual real world examples of absolute value inequalities so you guys can have a better understanding. Go ahead and submit your notes for this, and I will see you in the next class.